Thank you everyone for being here, first of all, and thanks Ring for inviting me. My name is Addhyan, I'm a lead data scientist at Groupon, and I'll be talking about how Groupon is leveraging data science to power local commerce. Now, let me first introduce Groupon real quick. We are global leader in local e-commerce, and we are based in Chicago. Now, what we do is pretty straightforward, pretty simple. We match or we provide opportunities for localites like us to get lucrative discounts from local merchants. And we are that platform right in the middle. Now, when I say global leader, I really mean it. That's because we have more than 300 million subscribers, more than 50 million active customers, and we have sold more than 1 billion Groupons to date. The good thing about our merchants is that they're not one-time merchants that they feature and then they're off. They tend to stay on our platform for more than a year. 90% of them actually stay for a long time. As far as customers are concerned, they buy a lot from us and they save a lot too. Me, I've saved $1,000 so far, so that's a good deal. Now, let me kind of brief you on what I'm going to be talking about. I'm going to be talking about how data science is the core part of Groupon and how we are functioning. So I'm going to be talking about a deal performance model. I'm going to be talking about when I did that, why I did that, how I did that, and then I'll try to cover the theme of this conference, which is innovation, technology, and career. The reason I'll be talking about this particular model is not because it's the most challenging work I've done at Groupon, no, but because it actually I learned a lot from it, and also because the theme is pretty. It's a good project to cover the entire section of theme. So that's the agenda. Now let me give you a quick background about data science at Groupon. This is the story of 5 years ago. When we were trying to push model into productions, we were trying to use a lot of data science, and this was basically data science, engineering, product, and business working together. This was because the pace at which business and product worked is totally different from that of data science and engineering. One of panelists, Ehsan, I think, he was talking about how it takes about 70% of the time just preparing the data. That's a lot of time. And the thing is that is one of the main reasons why the pace is different among all the units of Groupon. So as a first step, I'm that small dog, by the way, the white one, the cuter one. So what we did is we started talking to engineering team. The idea was to build a platform that could really minimize the time that we prepare data. So now let's talk about business. This is the model that we were working on. The idea was to rank order all the deals based on the amount they can generate from Groupon. And it was also to boost local deals so that users don't only see one sort of deal, but gives better deal diversity, and in turn gives higher revenue to Groupon. So a one-liner of this particular model is predict dollar amount that a deal is going to generate in a given period of time. This presentation actually this slide is actually quite interesting because at the top you will see the data science workflow. At the bottom you're going to see how business and product work. And then at the bottom is the timeline, and we're going to compare the pace of both the two units. So the first step is obviously acquiring right data, fetching it, cleaning it, and verifying it, whether everything is right or not. At the same time, business and product and data science basically discussing the ideation phase, finalizing the target variable, what exactly we would want to predict and stuff like that. This entire process takes a month. That's not sustainable. Next month, we are doing data analysis, which is writing scripts, analyzing results, debugging our code, verifying all the assumptions, which I think is an essential part of any data science model. You list out not just the assumption of a particular machine learning algorithm, but all the business assumptions that you take while building a model. And then trying out new approaches. At the same time, you're sharing all this intelligence insights with the business. So business now has a better idea and maybe you can go back to step one of business and come up with a better target video. At the same time, we're also discussing what are the modeling techniques we would want to use and stuff like that. Now, this is the third step where you're strategizing. You're strategizing your sampling technique, your missing data imputation technique, your outliers removal and stuff like that. And apart from that, more importantly, which model you're going to use. And business, because we know what target variable we want to predict, business is working on building the dashboard. Business is talking to data science and engineering to come up with a better dashboard that could target both local, which is local KPI, and global KPI. Global KPI is generally KPI for your entire organization or company, and local KPI is what you're trying to predict. Now, the last step is reflection, where you're doing out-of-time analysis, effect on KPIs, and how good your model is, and stuff like that. Now, till here, we have already taken 3 months. The last step for business is to do A/B testing, make sure that you have your particular model in production, and you can evaluate the overall impact of this model by the time it's April 16. Took me 4 months to do all this. It's just not writing code. It's also one of the things as a data scientist we do, which is convincing business units, convincing our product partners, working alongside our engineering partners to scale our model. Once we are done with that, this is one of our team. It's called Relevance, which is solely responsible to rank order all the deals in all our platforms, app, web, email, everywhere. So Relevance was using this product in May 16. We were testing it. Test was successful. They wanted to scale it to all the countries and stuff like that. A few months later, Goods Inbox Management, which is our email team. I hope you guys get a lot of emails from Groupon, and that team is responsible for that, for these goods email. Come December, there's a merchant onboarding team, which is making sure that when merchant comes on Groupon's platform, the process is frictionless, smooth. Later, social media marketing team started using it, and now the local sales team is going to use it. All these models are not same. They are different from each other, but there's minimal difference. It's not like one model is entirely different or anything. But as you can see, there are so many teams, or so many business units, I should say, are using the same model. Groupon currently does not have a centralized data science organization structure, which means all the data scientists are reporting to the same guy. It's not like that. We have a distributed data science organization structure. So every business unit basically has a few data scientists working for them. But this is something more hybrid. So you've got one model, or one data product, I should say, because it's not just a simple model, it's more than that. So it's one data product which is now being used by 6 different business units. And this is a more hybrid, more refined data science organization structure, which is working with engineering and product and business strategy team at the same time. And I call it distributed data science organization structure with a lot of business units under the same hood or under one umbrella. And this I think is more efficient than having centralized structure or various data scientists working for various business units. The knowledge sharing is better here. You're sharing intelligence, and basically same data or same variables are used across basically to solve various business problems. So fetching the data, that part used to take a lot of time, and I should thank the engineering effort that I saw a lot of engineers put. They basically built a platform for us. We call it QED, Quantum Engineering Data, and an automated modeling platform, which is Flux. So this was the state earlier. We used to fetch data from various sources, and so all these guys here, these are basically data scientists. So we used to fetch data from various sources, write queries, and do all of that. They have automated that. They have put a lot of logic so that the data which is coming out, and these are all inputs from data scientists, so it's verified by multiple data scientists. The data that we have is much cleaner, It's engineered data, so we know what features we can trust and which features which we cannot. They put it into various HDFS and HBase places. So you've got historical data, wherein you can go and get the data for training purposes. So you'd want a snapshot of data back for like 2-3 years, and then you have data which is used to score all the leads, which is basically used for production. As an end user, which is you are right here, you're basically hitting the API and you're getting all the data. It takes about an hour to basically get the data and make it or put it in a format the way you want to. You have all the entities available and everything as a data scientist that you want to see. So a data scientist is basically hitting the API, getting what he wants. You can now solely focus on what you like doing, which is analysis of the data, which is figuring out which algorithm, which modeling technique you want to use, what methodology you would want to try. And the good thing is you have your a good freedom on the kind of language you want to use. Not every data scientist uses R. Not everyone uses Python, right? And you just have full freedom to do whatever you want to do, or to use whichever language you want to use. And then just upload a simple R, Python, Java, whatever file it on the UI of this Flux. And that's how easy it is. And this is what you get with the same pace of all the different units, engineering, working with product, working with business strategy, working with data science. You basically get quick wins on regular basis. And now, this is again the last slide, but very important one, learnings. Innovation-wise, one thing that I've learned is, and it's personal choice obviously, do not compromise on performance. Make sure that your model is the best predictive model that can be built. Make sure each of your model is, you're treating that problem as a Kaggle competition where you would want to be the best. And also, learning is one solution doesn't fit all. Like, data decides which algorithm it would want to get fit in, not a data scientist, right? We just have opinion that this data might be good for this particular algorithm, but at the end of the day, whatever works is the best. Divide and rule usually works. In the sense, you can divide your data set into various segments, cohorts of users, or and then have various modeling technique working on all of those chunks of data. Thanks to again QED and Flux, we have better way to productionalize our model, much more reliable and much more quicker. And then the last thing, which is non-technical, is that distributed data science organization structure works. The only thing is you got to share intelligence with all the business units. Technology-wise, we came up with new feature engineering algorithm, which is one of the most important part of the architecture that I was talking about. And most of the conference that I go to, they talk about whether Python is better than R, or there's no versus, there's no competition. Use the best aspect of each of those algorithms. Career-wise, it's hard to quantify the work that you do, data scientist, but you gotta do it. You gotta have ability to put a dollar value in front of all the models that you build, and to do that, you gotta be in touch with various business units, and these are a few learnings. So career-wise, technology-wise, and innovation-wise. Last point, Groupon is always hiring. The link is at the bottom, jobs.groupon.com. Feel free to apply. Feel free to get in touch with me directly, and that's it. Questions? Yep.
Thanks for your sharing. It's very useful. I have a question. So for the building an effective marketing model, the two elements are the key elements. One is the data creation and the selection. two key elements. One is the data creation and the selection, wearable creation and selection. Second is the modeling techniques. So I wonder, could you share some experience regarding the how to create useful wearables and how to select the useful attributes?
Thanks to deep learning, these problems are getting easier to solve. When it comes to choosing which modeling technique, my general approach is build the best model for each and every algorithm and choose one based on performance on our time sample or your test data set. Now, I've worked at Groupon for more than 4 years now, and for at least 3 years I was writing a lot of codes. I have a lot of codes that automate these processes, fetching the data, which is actually automated modeling platform, fetching the data, and you have a ready-made code to build data, to build predictive models based on all the algorithms. And then for my job is basically easier. I know which algorithm works where and what kind of data set, and I just have to choose it and basically put it into the production. So it's very easy. Your first question, which was very important, very interesting, is feature engineering. What features that you would want to use? It depends on the algorithm, honestly. For example, you're working with random forest, right? There are a few features that could act as a noise. You would want to get rid of all the features with negative variable importance. For regression, a lot of features are generally not advised, right? So you would again want to, if you just follow the assumptions of regression to begin with, right? A variable that doesn't really have a linear relationship with your dependent variable, you wouldn't want to use it. So it depends from algorithm to algorithm, I would say. I haven't been able to come up with a one solution for all, especially for feature engineering, if that answers your question. I would want to answer your first question about data ethics. In my opinion, that's one thing that should be really, all of data scientists really should focus on is data ethics. You would want to ask yourself and to the organization that you're working at, where is your data coming from? Because I mean that's one of the things that I really is really important to me. Your question.
You're pretty terrific, because if you think about it, what you just did by taking and addressing that and saying that every data center should employ those standards, that already answered my question. You are 15 points higher than any other business in their satisfaction numbers. You're 79%. Groupon has done a pretty amazing job. So what I want to do is step back. How did you figure out when you were creating this deal, and I don't know any computer science.
Sure.
I really don't.
That's fine.
Okay, so how did you figure out, you create this product, it's new. How do you price it? How did you go to those potential businesses and say, we're gonna take, what, 40, 50% and give you marketing? I mean, that's Shark Tank level. How did you do the metrics, run the evaluation, and say, we're gonna be really aggressive and we're gonna ask them for this much money, but we're gonna really satisfy?
So first of all, data ethics is one, so as a data scientist, you go through these training at Groupon. It's not an option, it's a mandatory training, so you have to do that. Your question about how do you put dollar value in front of every product that you build? Well, sometimes business or product needs you, and sometimes just because you think these are essential things that business and product should know of, you have to not force it, but I think convincing power. And everyone has different convincing style, but you've got to have one style at least. So sometimes you have to convince business. A good way to really put a dollar value in front of every product is A/B testing, literally. A/B testing has given us a very good way to prove our worth, and that's what we do, or most of the data scientists do at Groupon.
Can you elaborate a little bit about engineered data? What it is and
Yep.
what role it plays in your data performance model?
Right. Let's say I give you data from January to December of 2016, but March data is missing. You know what? You'll build the model, and probably let's say you have a few data points in March as well. but there was some glitch engineering-wise, and as a data scientist, until you actually plot it, or until you see a bias in your model, you wouldn't be able to figure that out, right? A good way is to put logics in place. And over the past few years, data scientists have figured out those loopholes, those logics. And for us, it was just about communicating this to engineering team. They have put in those logic in the platform itself. So that's what I call engineered data that you can trust. This is just an example. There are multiple layers of intelligence that has gone while building that particular platform. But I mean, if that satisfies the question, if that answers your question.
So my understanding is you miss some data and you need to...
Not just miss, right? There could be wrong data,
Wrong data.
right? Okay. Those things are also part of those logics that you won't expect, this much traffic on Sunday. But let's say the data says that there's much more traffic on Sunday. So because you have those logics, you'll get those signals beforehand, before you actually start working on the data analysis or data modeling part.
But then why you call it engineered data? Why you call it engineered?
What would you want to call it?
I don't know.
Same, I mean, the guy who built it liked the word engineering. Any questions about product, engineering, Groupon, anything at all?
So going forward, as margins with food go up and restaurants are having a harder time, let's use that scenario, at getting people in, and they're grabbing more food at grab and go and different processes, maybe pop-ups, vendors, how do you take a problem like that? I'm just giving you an example, and then you tell me, because you're like this brainiac, how you're going to figure out if a portion of your market is going away. How do we get into that space? How do we do that?
Well, the good thing is that a computer is not doing that. A computer is not talking to merchants all the time. There is a human involved. Thanks to our huge team and their effort, we are able to basically address all the problems that merchant may have in present and future. So there's a human involved and one-to-one interaction that's helping us.
What kind of algorithm is behind your data performance model?
I would absolutely not answer that question.
He owns 7 patents. You think he's going to...
Let me ask you a simple question. So, as a customer to Groupon, usually if you run promotion, right? So, if you say have a discount like 20%, do you usually is the Groupon pay for that 20%, or is like you need to split with the business?
That's very case-to-case basis.
Oh.
Yeah. Time's over.
Are there any more questions?
You guys want me to leave? I can leave.
Okay, so I just had one question about kind of your distributed data science model. How do your data scientists stay connected with each other and kind of on the same page what's going on, being distributed across different departments?
So we have a community, it's called Data Science Central, where we meet, we review research papers, latest papers. We do it once a week, so that's pretty healthy. We don't only talk about data science at Groupon, but worldwide. What all different companies are doing, how they're applying various algorithms. And we publish outside as well. So KDD is one conference where we published our customer lifetime value and user engagement model last year. And we published a paper at IEEE as well. So the QED and Flux is actually published. If you want to look at the research paper, it's totally free. So we do that as well. So that's how we share the kind of work that we do.
So your data performance model, you adapt it to different data, and it can change over time, right?
Yeah.
Well, how do you measure the performance of your data performance model?
That's only doable if you're monitoring the performance of your model on a daily basis, right? So it's a very refined champion challenger system. We have a champion algorithm, we have a challenger algorithm, and we are monitoring the performance of all of these models. And let's say an algorithm A, was the best algorithm when you actually put the model into production, but after a month, the performance is degraded, so you would actually replace it with the other algorithm. But there's a threshold as well. So threshold in the sense, if none of the algorithm are performing, at certain level, you would retrain the model. That entire process is automated. So there's a data scientist.
Do you have a benchmark to?
I'm sorry?
Benchmark.
You want to know the benchmark? I'm sorry.
You do have a benchmark, right?
Yeah. We do.
You measure against the benchmark?
Yeah, we measure it against the benchmark.
Okay, well, thank you. Thank you so much for the, thank you.